Good morning, good afternoon, everyone. Today we have our 40th episode of Coffee and Compressed Air. I have here my cup of coffee. I have here my dog Douglas, who is a regular listener of our episodes. And today I would like to talk with you only about very nerdy things about the modeling and the simulation and how you actually can use also EasyCAS and bring questions. As I said before, I had a few conversations before our coffee, and I will answer all of them today. I will try at least. So I have just 20 minutes as usual. But on 16th of July, we're planning to have a big webinar where we talk about all our tools, applications, projects. And of course, our EasyCAS, our software, didn't start because we decided to be we saw an opportunity on the market and we wanted to sell a lot of licenses for the software. So it really started from my personal pain. I've been in the field for the past 13 years. So I worked in the research, I worked on development, I did my PhD in compressed air systems. I also worked as a modeler, as a calculator in my past work, in my past industrial work. So I had to calculate a few things, not few things, I had to calculate a lot of stuff for my colleagues, find right formulas, equations, find right tools, simulate some applications. And I was really struggling a lot because the tools that I used before in the research, they were not adapted for my day-to-day work. And basically how it happened, I worked a lot in the simulation modeling tools. I can name them here, you know them. So it's Automation Studio, it's Amasim, and some Simulink from, what was this, ACTE Simulation X. Again, they're not, of course, our competitors at all. We're not their competitors. We have completely different scopes. Because I couldn't find, I had to simulate or new products or new components or some systems or do some new development, and it would take me really long time. So it would be you set up your model for just a few cylinders in 1 week, then you have to run it and rerun it, and then you need to put the biggest pain that I had is to put so many parameters, and like you need to parameterize one cylinder drive, and there you need to put all the length of the cushioning. You need to put this and this and this, and if one component is missing, you need to actually find all other parameters for this component. So it is fine if you're a researcher. It is fine if you work in the pre-development of completely new systems, because it has usually quite good physics. Some of the software unfortunately don't have a compressibility models there that completely doesn't make sense for compressed air system, but very good for hydraulics. And then you just press the button, simulate, and then there is an error model. And I was, because it's the problem of the software, but it's because my problem, I forgot to find some parameter. This parameter didn't match with some, I don't know, maximum velocity of the drive, didn't match with some pressure drops, and you don't know where it is. So it doesn't show you doesn't locally show you. Of course, as a researcher or as an R&D engineer, you need to do many iterations. You get paid for this. You get a lot of frustrations, but you are the only person usually in the company who is responsible for this type of the calculation. So you have colleagues that come to you and ask you some stuff. You have then other colleagues that do, for example, CFD simulation. So I was doing the lumped parameters simulation, where you basically need the system. And when I started to work in the company, I worked for Emerson. So we were developing, I was working in the department that was developing a special systems. Not like very special. So it was something that you use the standard components, you need to put them together, you need to check some switching times of valves, you need to change some maximum flows for the customers. I would start using Amasim licenses that we had, And it was literally impossible in those times to deliver the results because, well, yes, I was not professional enough also to use another software. I had to study a lot. I had to go to the courses also of this, although of course, like I knew how the physics works, what should I put together, but it was still really people that like nerds in this in this chat, in this live event, you can really understand it, that it's a lot of things that has to be considered, and usually you need to have just one person in the company who takes care of this. And recently I spoke with one of the colleague from the field, and he comes from the compressor world. And then he asked me, "Oh, you use your EasyCAS. Why don't you use like some other AMSIM softwares?" And then I was trying to explain that our EasyCAS is, first of all, completely different logic and completely different application for the user, because we developed our own code simply because of the pain of engineers that need to invest a lot of time, and our code works completely different. It has completely different logic that actually reduces your time for the simulation, for the modeling. It's not a 2D simulation, it's a 1D simulation, but it exactly satisfies the requirements for plant managers, energy managers, anyone who designs a pneumatic system, a compressor system, and doesn't have to use 1 million tools and Excel tables, but actually have one tool that can be used there. So I want to show you now the principal difference, and if you follow us, of course you know it, but I just want to show why we wanted to develop our own tool that makes our life way easier. And now we actually can calculate system just in a few minutes rather than in in days. It will not give also any problem. So let's go here, and here you can see very simple system. So it's just one application of pick and place. You have your 4 cylinders, 2 ejectors, and how usually, if you are an engineer who designs pneumatic systems and need to check those pneumatic systems, so how usually you check it? You go to calculate. You need to understand what is the diameter of cylinders that you need to put. You put your system, and then you usually put the supply flow and pressure that will go into this machine, and then basically it just goes into the system. And then the programs usually calculate here the final force that is recalculated, the final velocities, and so on. But sometimes you even don't know if the velocity is correct, if things are correct, but you need to go, you need to be sure that everything is done perfect, so it's calculated. What is the huge difference between our software and other softwares, rather than that it's extremely easy just to drag and drop things here? You already have the components that you don't have to parameterize, meaning that you have components from ISO standards, you have components from catalogs that you actually don't need to put and look for the technical data, such as consumption at a certain pressure levels, noise levels, materials, and so on and so on and so on. Another thing is, for example, that you have regulators, you have pipes, and you already have all the material information here to calculate the pressure drops. So meaning that in the pipe, you as engineer, you choose like what is the material, like is it aluminum, copper, or something else, rather than actually going into other tables and looking what is for the coefficients of the of loss coefficients. So, and basically what we have here is that we always start from the calculation of the we don't go from the supply to the demand, but we go from the demand to the supply. And this is a huge difference. And this is actually based also on the new upcoming standards. It is extremely important because we always need to calculate when we size systems, when we size compressor systems, when we have here other production lines, for example, and multiple of them, we always need to know what is actually the demand, well, how much we need to provide in order to produce, in order to save also energy and don't oversize our systems. Because conventional softwares, they don't tell you that the system is oversized, because you simply say, okay, here I have a 2000 liters per minute, 8 bar, what I get here, and here you get some dynamic parameters. Instead of this, we reverse the problem and we say, here you have a different consumers, users of compressed air: cylinders, ejectors, air knives, jets, nozzles, and so on and so on and so on. I need these components to provide me this force, this cycle time, this stroke. I have this frictions there, this tube length. What is the optimal pressure and flow to supply all these consumers? And this is extremely, extremely important here, because we're actually sizing the system correctly. And I am really gonna, until my retirement, I will be pushing in order to size the system according to the demand, and not just design the systems taking the components that already just sitting on the shelf. So this is the first way. And then from the demand side, from each single component, it then calculates physical parameters back, and back until the compressor, meaning that here we have, for every single parameter, we have the pressure drops, we have also the flows, we have here we can also see the big pressure drop. For example, in this case, we have a very big pressure drop that should be replaced. And in conventional softwares, they don't give you these alarms. So you just simply need to find in all your millions of actuators, you simply need to find where I have the problem. Here I already have the problem because I can see it, because I put in my optimization criteria what it has to be the maximum pressure drop in order that the software will find this component. So, and this is basically, this is the first huge thing, as well as the this kind of science range. You also can see it helps you then to check the velocity of the cylinder. So it has, the logic here is way more intuitive, because it's more simple it is, more work we actually put also on the background for this. And here you can see that it's more intuitive. You just put the components together, and then you can see what has to be also the supply of this. And talking about this, I would like to go then on the also step further, because what is also extremely important is that not all consumers work also in the same time. Not all end users of compressed air work at the same time. So we have a certain cycle for them. So we also can set up a cyclogram. For example, let's say my maximum time is 20 seconds. And I actually can start setting up the cyclograms to get already flow profiles. So meaning that I can switch on, switch off different consumers, different users. And then basically, let's go, for example, here, and then I can actually see the actual flow profiles and pressure profiles. So we why it is good, because we actually can simply get into the system. We simply can get the understanding for the sizing for the filter. So here we have the flow profile over the cycle, the maximum flow, and so on. We also know what is the pressure, what are the pressure drops also inside the system. So this gives us a lot of information. I don't know, there are some softwares that can give you this information, but I know that in pneumatics it's doesn't work like this. It's a bit hard to get the cyclogram in some softwares, only when you actually can calculate the logic of those components. So, and this is the second. And the third, well, the fourth, we'll have a lot of them. Another thing here is that you don't have to really put every single component and get your calculations done. What I mean, of course, here we have some elbows, we have here some connectors that you can find here. We have some other connectors, but I actually, in order to calculate the pressure drops, I actually can get into the details, but sometimes I just want to have the first idea just of the sizing, just of the flow. I have, for example, here my flow, and I want to see, here I have a undersized pipe. Here the flow I need, for example, to size my filters, to size my regulators, my air preparation block. So, and I can go in details as much as possible, or I simply can just put this as one consumer, couple of consumers, and I can calculate what are the pressure drops, what are the flows for two production lines that are, for example, shut down in a certain sequence. I don't have to put, for example, here, you see, I didn't put the exhaust because I simply just didn't have time to put the exhaust. And now I can put and connect, so it looks everything correct and pretty. But in reality, the software already will tell you if the system, if something is not connected. So here it says, listen, here it's not connected. You need to put it to connect it here. But the calculation still happens. And if there is something really critical that is not connected, then the software also will tell you. So it's I wouldn't say that it's like safety from a fool, because there are no fools in engineering, but in general, it's extremely easy to start with this. So it's, you take this, you press right mouse and you remove the connection, and you connect only red with green. So you cannot connect red with red. The software will simply just will not give you an opportunity to connect red with red. Green with green, extremely simple, extremely intuitive. So if I change here, for example, some pressure regulation and do again like the calculations, you see that I have now a problem, and the problem say this has to be your pressure level, and you need basically just to change this pressure level for this regulator. So in conventional softwares, if you use like a big simulation tool, of course, it will not give you this mistake. It will give you crazy results in the output of the cylinder that are physically impossible. And as an engineer, you actually need to know what you expect at the end. And this is extremely difficult things that I noticed, because you need to have in your company usually one person who knows the system very well. And once he simulates this or she simulates it, they actually need to know what to expect. And here you don't need to know what to expect, because the software will just simply tell you, okay, this is your maximum velocity, this is your calculated flow rates for this velocity. So it will give you all the possible information for cylinders, for other applications, and so on and so on and so on. What is the peak of flow rates? What are the usable forces here that you can have? All this information that actually makes sense, and we could achieve it thanks to two things. Of course, amazing team of engineers, mathematical models that we validated in the lab. Please note that they're validated on the test rigs. I'm going to stop sharing. There are a lot of softwares that actually don't validate on the test rigs. They simply put some white papers to calculations, and I was actually shocked about it when I learned. when I remember I put some test rig, and I saw that they didn't meet the results of the simulation. And another thing that is extremely simple to start. So you can actually check the system within a few hours, maybe days if it takes more time to set it up. But it's actually not a very sophisticated modeling and simulation software for this. So of course, it doesn't have a 2D simulation like calculations of the velocities of flow over the time. This is sizing that gets like the maximum and minimum parameters. We have an online tools for cylinders, for some other applications for the 2D simulation, and I think at some point we integrate also here. But you actually don't need it. When you do only the sizing, when you do the energy consumption calculations, for example, you want to check if the system will work in the lower pressures. You don't need to have the really 2D simulations, and you don't need to have the if you only want to check the dynamics of the equipment, then yes, you need to have a 2D simulations. For these applications, it's really not necessary, and this is why we are building. We are continuing. We are adding also more features. We see engineers that use it for the greenfield, for example. They plan and lay out the full piping system. So they actually use the software. We see the engineers that use it for the pneumatic diagrams calculations. We also see energy managers that use it for audits, meaning that we simply check the system, how it works, how it performs, what are the possible energy saving measures there. What if I do a multi-pressure system? For example, I use booster at some point. For all this kind of application, the software can be used, and I really love it. I really love it every time I open myself. I think that's amazing what we created, because I can size compressors, I can check all possible, I can do my audits, I can do system optimizations from production lines to the entire facility. And of course, we have some other things like web tools, calculators, all these kind of things that can calculate every single separate component. That is also extremely important, the reporting system and so on. But here it's my really I'm proud as an engineer that we could develop this with our team, because it is a fantastic it is a fantastic tool. It's extremely simple, and I really couldn't find any way to softwares. And I invite you to try it. We will be launching soon more and more features, more and more updates, and I hope to see you soon in our next coffee and compressed air, as well as follow me, follow Danny, follow also our Direktin page, where we have more announcements and new updates. Thanks everyone, and have a wonderful day, and enjoy your coffee. Mine is already cold, so I need to talk less in these workshops, in these talks. Thank you and goodbye.